Okay, good morning Year 8. So we're going to start with marking yesterday's work. So if you get that in front of you first, pause the video and mark these first 6 questions. Just note the first 3 are positive, in fact the first 4 are positive, but E and F are both negative gradients. Okay, when you've marked those, we'll have a look at these ones. So these ones I did put a star by, okay, because the scale changed. So just be aware, okay, that the scale here is 1 across, takes 2 squares, so this is 1 across, and how many do I go up? 1, 2, 3, 4. So the gradient here is 4. Okay, same on this one. It's negative because it's going the other way. All right, but when I go 1 across, I go 1 down, so the gradient is -1. I don't put the 1 in, I just put negative x. And on this one, again, 1 across, I go 1, 2, 3 up. Okay, so the gradient's 3x, and it's going through 0, 0. I don't need to put the +0. And then the last 3, okay, so both scales have changed. So every time I go 1 across, I'm going 2, 4 up, because the scale here goes up in 2. So it's 1 across, 2, 4 up, gives you a gradient of 4. Negative gradient here, but every time I go 1 across, okay, I'm going 1 down. So you might need to draw a slightly bigger triangle and go 2 across, 1 down, and get a gradient of start that again. Go 2 across and 2 down, and so you get a gradient of -1. Okay, and then L is negative again. But if I go 1 across, I have to go 6 down, and again it goes through the origin. So the intercept would you just put plus? Well, you wouldn't put anything because you're not going to put +0. Okay. All right. Let's have a look. So we're going to start today, and the title of today's lesson is Parallel Lines, and we're going to look at how to find equations of parallel lines. So the first task you have to do is you have to find the equation of the blue line in both on both sets of axes. So just as you were doing yesterday, find the gradient, find the intercept, write the equation for both. Okay, so just pause and get that done. So once you've done that, I want you to think about these 2 questions. What can you say about the pair of lines, the red and blue lines here? And what can you say about the pair of lines here, the red and blue lines here? And what do you notice, or what can you say about their equations? So just have a think, maybe pause that for a minute. Have a think, what can you tell me about these 2 lines? What can you tell me about these 2 lines? What do you notice about their equations? Okay, so let's come up. So what did we get for the equation of the blue line here? Well, hopefully you will have got y equals 2x plus 2. The gradient is 2, and it's going through 2 on the y-axis. And hopefully on here you will have got that the blue, if I can get it to work. No. No, not going to work. Okay, I'll type it in. So it's y equals 3x plus 4. Okay, is the equation of the blue line for this one. Okay, so again, a gradient of 3. All right, and it's going through 4. So what can you tell me about this pair of lines here, this red and blue line here? Well, hopefully you will have noticed that they are parallel, and it's sort of given a hint in the title. And you'll have noticed that these 2 lines are also parallel to each other. So how does that relate to the equation? So if I put the 2 equations together, okay, you will see in this instance, okay, the number multiplying the x is the same. So in other words, the gradient is the same. And we have the same over here. Okay, the gradient on these 2 equations is the same. It's both 3. Okay, so what we need to notice is that parallel lines have the same gradient, and that's quite a key point to understand. So make sure that goes in your notes somewhere and highlight it or box it so it's something you need to learn. So when you've done that, have a pause and tell me which of the lines I've written here are parallel to y equals 4x plus 3. So pause. Okay. So we're going, well, it says here, parallel lines have the same gradient, and we learned in previous lessons that the gradient is the number that multiplies the x. Okay, so the gradient of this line here is 4. Okay, so I'm looking for all the equations here that have a gradient of 4. Well, this one here does, okay, and this one here does. This one has a gradient of 5, so that's not going to be parallel. Let's put it over here. This one here has a gradient of -4. Well, that's not a gradient of 4, so this has to come over here out the way. This here has a gradient of -3, that's not 4. This has a gradient of 4, so that is parallel. This has a gradient of 4, so that's parallel. But this has a gradient of 3, so this isn't. Okay, so these 4 equations would be parallel to this equation here, or this line, sorry. These 4 lines here would be parallel to this line here. Okay, so there are an infinite number of lines parallel to this one. Okay, all I'm doing to get a new line is to have y equals 4x and then add or subtract something after it. Okay, so what I'd like you to do here is write down the equation of a line parallel to each of the following. So it can be any line, okay? You're all going to get different answers for these, okay? But what you need to remember is the gradient has to be the same to this line here, and the intercept, it doesn't matter what it is. So again, the gradient has to be the same here, but the intercept can change. So for all of these, write down the equation of a line that's parallel to it. Question 2. All right, write down the equation of each of the following lines. So it has to be parallel to this line here. So that tells me the gradient, and it's going through 0, 2. So 0, 2 is the intercept. So you should be able to write out the equation of that line. Okay, so similarly with these ones, work out what the gradient is for these two, and then work out the intercept from the equations there. All right, question 3. All right, write down the equation of the line parallel to line 1 passing through A. So, okay, you need a line that's parallel to this. And remember what we said was if it's parallel, it's got the same gradient. So find the gradient of this line, and then you're given the intercept here. So you can work out the equation. Find the gradient of this line, okay, and then this is the new intercept here. All right.